just going to look at, solving differential equations. But eventually we'll get into some applications. This is going to be the section where we get to do our Newton's Law of Cooling, and possibly our pizza roll experiment. If we can get that worked out, we'll try it. So you have already been solving super simple differential equations. Sometimes you would be given a problem like this, and you would just multiply both sides by dx, and that would give you dy equals 2x plus 5 dx. And then to solve so that you get a y, you just integrate both sides. And when you integrate dy, you get y. And then you just integrate 2x plus 5 dx. So that would be x squared plus 5x plus c. Right. So we've already been doing that. There's been a few where our book would give us differential equations instead of just telling us to integrate something. But this is so much like just integrating that you probably just integrated 2x plus 5 without really thinking about moving this dx over and integrating both sides. So here, we've already been doing this, but today we're going to get into ones that are more complicated than this basic differential equation you've been solving. So, in order to solve a differential equation, you must separate variables. All x's on one side and all y's on the other. I might want to jot that down because that's kind of one of the key things that we'll be doing. Do some differential equations today, Coach Swift. This is the easy one, right?
What do you think of that conversation? I think you can figure out what we're talking about. Conservation. I like conservation.
Conversation. Okay. So, let's look at a differential equation that is more difficult to solve. Alright, so, in this case, and I did this because our textbook does this a lot, that we use y prime here. But I really don't like y prime for differential equations because it makes it a little more difficult to separate your variables. So anytime I see y prime equals 2x over y, I just go ahead and change it to dy over dx equals 2x over y. So before you can integrate, and what we need to do is integrate so that we are getting rid of our dx and our dy. The dx and the dy have to be in the numerator, they have to be in the top, and all the x's have to be on the same side as the dx, and all the y's have to be on the same side as the dy. So, like in this case, technically in this case, the easiest thing to do is just to cross multiply. Because if we cross multiply, then we've got y times dy equals 2x times dx. You cannot always cross multiply, but in this case, it's going to get your x's on one side and your y's on the other. And everything is in the numerator, because if your dy or your dx is in the denominator, that's not going to work out for you. So once you get these separated, all x's on one side, all y's on the other, you can integrate both sides. And so when we integrate y, we get y squared, divide out front by 1/2. And technically right here we should get a plus c. And I'm going to put a little 1 right here because that's our first c. We're going to get another c on the other side. So we're going to integrate 2x. So that gives us just x squared plus c. And I'm going to put a little 2 right here. So at this point, you have solved the differential equation because you don't have a dx or a dy anymore. Now, depending on what they have given you, you might see this given in a lot of different ways. So this is a point where you're going to check the back of the book, see what the answer looks like, see if you can get it to work to match it, or if it's multiple choice, you're looking at your answers to see if you can get that answer that's there. Because technically right here we have solved it, but usually the answer is not given like this. So on a problem like this, there's an x squared and a y squared. When we have an x squared and a y squared, that's a conic section. If you remember from pre-cal, conic sections were your circles, your ellipses, your hyperbolas, and parabolas. So usually with this, in this case, an x squared and a y squared, when you move one over to the other side, it's going to be negative. So this is a hyperbola. Typically, the standard form for that is like you put the x squared and the y squared on the same side. So that's probably what you'll see here, but you don't necessarily have to use your answer choices in the back of the book to sort of lead you there. If it's free response, you can stop here. So if we're trying to get everything on one side, I could move that 1/2 y squared over to the right and move the c2 over to the side. So we'd have c1 minus c2 equals x squared minus 1/2 y squared. And our c's are unknown here, right? So since c is unknown, you've got an unknown number minus another unknown number, right? So I'm going to do this. I'm going to let c equals c1 minus c2. So I'm just going to turn this into a c right here. Now, on the next problems we're going to do, I'm going to show you a shortcut so you don't even really have to do that. But for right now, to kind of understand what happens with those c's, we'll do that on this problem. The other thing you're going to see here is that a lot of times they don't like to leave a fraction in the answer. So if we wanted to get rid of that 1/2, what could we do? Multiply everything by 2. If you multiply by 2, 2 times 1/2 is 1, so it'll go away. So if you multiply the whole thing by 2, you end up with 2c equals 2x squared minus y squared. But 2c is 2 times an unknown number, which is still just an unknown number, right? So basically, anything you do to a c, you can really just still leave it c because it's still an unknown number. So more than likely, this is what you would see the answer left as. So C is an unknown number. We don't know what it is, right? So basically, anything you do to a C, it doesn't really matter if you write it down or not, because it's still an unknown number. So 2 times an unknown number, is still an unknown number. So we can just call it C all the way through. We don't necessarily have to distribute to our C. We don't have to like add, subtract, multiply, divide to our C, because anything that we do to the C still makes it C. Yep, so this is what we would probably see the final answer as. Okay, and on the next problem I'll show you how we can simplify that C stuff a little bit, because it can be a little confusing. Okay, so here, I'm going to let you copy these down. One thing that's really important is knowing whether or not something is separable. Because if it's not separable, we cannot solve it. And we're not going to learn how to solve it. I'm going to save that for whenever you guys take differential equations in college. Or maybe till never. Depending on what your desire is there. I actually never took differential equations. Meredith, you had like an option between it and another class, and the other differential equations wouldn't fit in my schedule, so I cannot help you much beyond what we're going to do here. And even if I had taken it, I would have forgotten it by now, probably. One thing that we're going to see them used for is Newton's law of cooling, but anytime you're comparing like rates of things, it's kind of they're kind of like a related rate problem in some ways. And I'm sure there are lots of other big applications. We're mostly going to see it with Newton's law of cooling and like exponential growth and decay are the things that we're going to look at it for. Alright, so if we look at A, and we're trying to separate our variables here, the first thing you would have to do if you're separating these variables is you'd have to multiply both sides by dt, because you cannot integrate both sides with a dt in the denominator. So now, are we going to be able to split these apart? Is there any way I can get this y over here to the other side? I could distribute, so I'd have y dt plus t dt. So if I here's the problem. If I divide by y, I've got to divide this by y. And so it would get rid of this y, but then it'd put another y over here. Alright? So dividing by y won't get you there. You could subtract this y, but if you subtract the y, the dt's got to come with it. And then you've got a dt on the other side, which is not going to help you out. So this one is not separable. That one's a no. Generally, if the two variables are separated by a plus or minus sign, not in every case, but in a lot of cases, it's going to be hard to separate those. Okay? Let's look at B. The first thing we'll have to do is multiply by dt. That's pretty much the case every time. You cannot solve for a differential equation with the dt in the denominator, so you need to get it out. So ty over t plus 1 dt. So if we're trying to separate our variables, we need to take this y and get rid of it. Can we do that? We could divide by y, or you were going to say multiply by 1 over y. Either one of those are the same right there. So if I multiply by 1 over y right here and right here, then the y's here, since you're multiplying, the y's will cancel, right? Because it's not t plus y, but just t times y, so those will cancel. So that will give you dy over y equals t over t plus 1 dt. Okay? These are separated. It is okay for your variable to be in the denominator. It is not okay for your dy or your dt to be in the denominator. So dy and dt are both in the numerator, and all the y's are on the left, all the t's are on the right. So this one is a yes. That's separated. For right now, I'm just asking you to separate them, so yes. If we, as we do these problems, we're going to actually integrate both sides. But for right now, we just want to know if they're separable. I used to say no on C. And then, right as it is right now, it's definitely a no. And why would it be a no? Not because of the plus. It's because I'm pretty sure I just messed up when I wrote this down. I've got a dy and a dt. What have I got over here? I've got an x and a y. So I can't separate variables whenever I've got three different variables. But I'm pretty sure that that's just because I messed up whenever I was writing this down. So let's change this to a t right here. And so I also, before I had the x and the y sort of messed up there, even if it looked like this, I used to tell kids this was not separable because of the plus sign. But I was wrong. Because, watch this. Whenever I have, like, x squared times x to the third, what is that? X to the fifth, because I did the 2 plus the 3, right? So when I have e to the t plus y, I have e to the t times e to the y. Alright, so if I break it apart like that, now I could multiply both sides by dt. And now can we separate these variables? Can we get rid of that y? We can. The e's got to go with it, but it's fine for the e to go with it, because e's just a number, right? So we're going to divide both sides by e to the y, which probably you're going to want to make e to the negative y dy equals e to the t dt. So this one is also a yes. That one's really tricky though, because it was my example of no for several years till I realized that I was wrong. I can't remember that. I should have written down in my notes which student it was that set me straight on that one. I think it was somebody last year, but I can't remember who it was. Yes, I said, can't we make that e to the t times e to the y? Yes, we can. That would be an excellent idea. All right. So here's our next one, and this one we are going to solve all the way. So we've got dy over dt equals y squared times e to the negative t. So first thing you want to do is multiply by dt. That's pretty much standard. The only time you might not do that, although technically you are when you do it, is when you can cross multiply. But so here we get dy equals y squared e to the negative t dt. Alright, now we need to move that y squared over to the other side. What could I do to move it? Divide by y squared. And to make this easier to integrate, instead of leaving that dy over y squared, I'm going to make it y to the negative 2 dy equals e to the negative t dt. Okay? I think getting these separated is the most difficult. Once you separate them, now you need to integrate both sides, but these are usually fairly simple integration. Sometimes you get a u substitution. In this case, we're going to have a very small u substitution on that right-hand side. So when we integrate y to the negative 2, we're going to have y to the negative 1, divide out front by that negative 1, so we just get negative 1, y to the negative 1. Technically, we should put a plus c here, but I'm not going to. Because what I'm going to do is I'm going to just wait and put the plus c on the other side here, and that's the plus c for both sides together. We don't have to write the c1 and c2 like we did on the last problem. You can if you want, but I'm just going to put them together. So here, if I were doing this, my u is negative t, so my du would be negative dt, which means I need a negative here with my dt and a negative out front. And then so that is negative integral of e to the u du. What do we get when we integrate e to the u? E to the u, right? And since we here have that negative out front, what is our u? Negative t. And then I'm going to put the plus c over here on the end. And so, at this point, technically you're done. I'm not really sure what they'll leave this looking like. I think they'll probably do this, negative 1 over y equals negative 1 over e to the t. Move those negative exponents back down to the bottom. And on something like this, they might do something like this. They might say like 1 over e to the t minus 1 over y equals c. Whenever you're doing your homework, I just want you to check the back of the book on the odd ones and try to get your answer to match theirs. On the evens, you can leave it, really, you could leave it, technically you leave it here if you want. I don't love negative exponents. I like to move them sometimes. Okay, questions?
Yeah.
A little bit. All right, here's just another one. I do not like y prime. So if I were you guys when I was writing this down, I would just go ahead and change this to my dy over dx. Now you can tell this one's going to be probably a little bit more to integrate than what we've had before because we've got a lot of things going on here. We need to separate, so the first thing I need to do normally is multiply by dx, but I can't do that here until I get rid of this 3xy. So I'm going to move that over to the other side. So I'll have 1 plus x squared dy over dx equals negative 3xy. And now you can multiply by the dx. So I need to get rid of this y over here on this side. How could I do that? Divide by the y. And so I've got 1 plus x squared over y dy equals negative 3x dx. I also need to get rid of this 1 plus x squared over here with the y's. How do I get rid of it? Divide by 1 plus x squared. It's usually, once you get stuff to either side, like remove that 3x, it's usually division to move it. Sometimes multiplication, I guess, if it's in the denominator. So if we divide by 1 plus x squared here, it's going to cancel, and 1 plus x squared here. So we end up with dy over y equals negative 3x over 1 plus x squared dx. There is usually a differential equation problem on the AP exam on free response, and if you do not get your variables separated, then you get 0 points on that section, which typically is worth 5 or 6 points on that free response section, because these are long problems. There's lots of steps you have to get. So when you see one of these, you've got to get all the x's and all the y's separated. Even if you have to make it up, even if you don't know how to do it, just put all the x's on one side somehow and all the y's on one side somehow, and then integrate. You're gonna miss part of it if you have to make it up, but you might have something where they'll grade with you and give you some credit after that. But if you don't get the x's on one side and the y's on the other, then there's no hope for you. You won't get points on that part, and they're typically worth 5 or 6 points for that part of the problem. That's the only thing they usually give that many points for. Once we get here, we've got to integrate both sides. And I'm going to hold off on that left side for right now, because the left side is a really easy integration. What is the integral of dy over y? Natural log of y. I'm going to hold off on that, though, because the natural log of y, what I want is I want to integrate both sides at the same time so that I can put just 1 plus c. Technically, if I integrate one side first and don't put a plus c, then I've done an illegal move there. So I'm just going to leave this integral of dy over y for right now. I've got to do a u du substitution over here on this other side. So what would the u be in this case? 1 plus x squared. And so that means du would be 2x dx. So we're going to have to multiply. What do we have to multiply there? By negative 2/3, which means we have to multiply by negative 3/2 on the outside. So we've got negative 3/2 integral of du over u. Okay here? Alright, now I can integrate both sides and I can put the plus c on the end. So when I integrate over here, I get natural log of absolute value of y equals, and then I'll have negative 3/2 natural log of the absolute value of u plus c. We cannot. Since it's not definite integration, indefinite. We cannot leave it as a u. So we've got to put the 1 plus x squared back in. So we've got natural log of the absolute value of y equals negative 3/2 natural log of the absolute value. Actually, if I've got 1 plus x squared, do I need absolute value? 1 plus x squared is always positive. So if you leave it, I don't think it's going to hurt anything. So, whenever we do this problem, technically we're done if it's for response and they haven't asked for anything more than to solve this, we could stop. But most of the time, from a problem like this, they'll say solve for f of x equals y or something like that. Meaning it's got to be solved for y, like y equals here. So if we've got to do that, what do we have to do to get rid of that natural log? Raise it as a power of e. Alright, and if we do that on this side, we have to raise all of this as a power of e. So over here, those just cancel out. You get a y. The absolute value bars are going to go away. I don't have a really good answer as to why, but I know that they always go away in what our book has there. So now, right here, I've got this e to the negative 3/2 natural log of 1 plus x squared plus c. There's some properties of exponents we need to remember to be able to do this. So this number that's out front of the natural log, I can move it to the inside. What does it become if I move it to the inside of the natural log? I remember. It's going to be an exponent. Okay? So like if I had, like a more simple example, if I had 2 natural log of x, that's the same as natural log of x squared. Right? So if you have a number out front, it can go in as your exponent. So the reason that is good is because if we do this, we've got e to the natural log of 1 plus x squared to the negative 3/2 plus c. And e and natural log can cancel out here, but let me remind you of something we did on the problem just a minute ago. This plus c right here, it is not a plus c just out to the end, it's in the exponent. Okay? So, if I had something more simple, it's like I've got e to the x plus c. Alright? In the last problem, or not last problem, but a couple problems back when we were separating those, what did we do with our e to the x plus something? We made it e to the x times e to the c, right? We've got to do that here. So we've got y equals e to the natural log of 1 plus x squared to the negative 3/2 times e to the c. No, we're going to get rid of it here on the next step. If you don't want to write that step, that's fine. Now, e to the c is an unknown number, right? So e to the c is still an unknown number, right? So I'm going to let e to the c equals c. So I'm going to end up with y equals, the e and the natural log will cancel here, so I'll have 1 plus x squared to the negative 3/2 times c. Or, we'll probably see this written like this, c over 1 plus x squared to the 3 halves. Questions? These become pretty detailed. Another thing I should have pointed out as we were doing this. On these problems that are usually on the free response section, if you do not put a plus C, because typically they're going to ask you to like plug a number back in and find that C when we get further along. If you don't put a plus C, usually that's at like 2 points, and if you don't put a plus C, you're not eligible for like the next 3 or 4 points. So you cannot forget the plus C. Make sure you've got the plus C. All right. I thought I had another one. I think we'll be okay. All right. So your assignment is going to be on page. Where's it down? Where did I put it? 382. And we're going to do 1 through 8. So go ahead and get started on that.